Now I will be talking about the epithelia. In this we will be learning what is epithelia and what are the different types of epithelia and what is the basis for the classification of the epithelia. The likely questions on this topic are: define epithelia, classify epithelia with examples, write briefly on transitional epithelium. At the end of the session, you will be able to answer these questions. Where from the term epithelia is derived? It has originated from the Greek word epithelia, which means epi means upon, thelium means nipple. So the word epithelia is derived from Greek. The definition of epithelium: cellular avascular tissues covering the surfaces and lining the cavities of the body are epithelia. So the definition for epithelia is cellular avascular tissues covering the surfaces and lining the cavities of the body. So it says epithelia contains cells and there is no blood supply for the epithelial tissue, and it covers the surfaces of the body, for example skin, and lining the cavities of the body, that is pleural, pericardial and peritoneal cavities. And not only these serous cavities, the tubular structures, for example the digestive tract and respiratory tract, the urinary tract, wherever the word tract appears, is also lined by the epithelia. Epithelium is singular, epithelia is plural. So make a note of it. Epithelium is singular, epithelia is plural. So we are seeing the epithelium. So we are seeing the cells which are lying on a basement membrane. Okay, this is the basement membrane. So these are the basal aspects of the cells, and this is the apical aspect of the cell, and this is the connective tissue which is supporting the epithelial tissue. So what are the characteristics of epithelia? Let us see. So the cells are resting on the basement membrane, and the space between the two cells is very little. So little intercellular space, and they do not have blood supply. So that's why they are called avascular. So when they are avascular, where from they get the nutrition? So by diffusion from the adjacent tissue. And the epithelia are avascular with the exception of stria vascularis of internal ear. And the epithelia have nerve supply. And developmentally, these are derived from the three germ layers. So what are those three germ layers? Ectoderm, endoderm and mesoderm. So there are epithelia derived from ectoderm, and there are epithelia derived from endoderm and similarly from mesoderm. For example, skin is ectodermal in origin. The lining epithelium of the gut is endodermal in origin, and the lining of blood vessels is mesodermal in origin. Then the cells, the epithelial cells can undergo metaplasia. So they can get converted into one type to the other, that is called metaplasia. And they exhibit polarity. So the bases of the cells and apical cells, they will be different. The basal cells, the bases of the cells is a less modifications, whereas the apical cells, they show more modifications. For example, here you are seeing at the apices of the cells, the cilia are there. So this is a respiratory tract epithelium. So basal and apical polarity is exhibited by the epithelial cells. And the epithelial cells, they can regenerate. Once they are damaged, there is replacement. For example, the skin. So the cells that are damaged due to operations, they will regenerate. Similarly, in the gastrointestinal tract also, the cells will regenerate. The best example for regeneration is the uterine endometrial lining cells, so which will be lost in the monthly menstrual cycle, and they will regenerate. Then if you observe, this is the nucleus. So you can observe the nuclei in different heights in this epithelium. And this type of epithelium, we call it as the pseudo-stratified epithelium because it is having cilia. We are calling it as the pseudo-stratified ciliated columnar epithelium. And the shape of the nucleus and the shape of the cell, they have a relationship. So the nuclei tend to conform to shape of the cell. So the characteristics of epithelia, let me revise. The cells rest on basement membrane with little intercellular space. They are avascular, but they have narrow supply. The epithelia are derived from all three germ layers. They can undergo metaplasia. They exhibit polarity. They are capable of regeneration. The nuclei tend to conform to shape of the cells. The epithelia are broadly categorized into those covering and lining membranes and glandular epithelia. So the epithelia are broadly categorized into covering and lining membranes and glandular epithelia. So what is this covering and lining epithelia? These are sheets of cells covering the surface of a solid structure or lining the internal surface of a hollow tubular structure. For example, skin. What is this skin? It contains sheets of cells covering the surface. So then, what about the example for lining the internal surface of a hollow tubular structure? So the example is the digestive tube, which contains the epithelium and its internal surface. Next is the glandular epithelia. It consists of cells lining the secretory parts and ducts of glands. So, the glandular epithelia consists of cells lining the secretory parts, which are known as acini, and ducts of glands. Example is the salivary glands and pancreas. So, the broad categorization of epithelia is into covering and lining epithelia, covering and lining membrane with one layer thick, which is known as unilaminar or simple epithelia, or more layers of thickness, which is known as multilaminar or stratified epithelia. Then the other one is the glandular epithelia, which lines the ducts and secretory units of glands. So, which will develop? The glands develop as outgrowths from the epithelial lined surfaces. What is the criteria for classification of epithelia? Because the epithelia are formed by cells of different shapes with surface specializations in some cells. So, taking these three criteria, they can be classified into different types. So, what are the three criteria? Number of layers of cells, which indicates the thickness of the epithelium. Shape of cells, where the apical surface, according to their height, their shape will be. Then at the free surface of the cells, it shows specializations. So, surface specializations is another criteria. So, let us see the classification of it. The epithelia are classified into covering and lining epithelia and glandular epithelia. The covering and lining epithelia are further classified into simple, stratified, transitional, pseudostratified. The glandular epithelia, exocrine glands and endocrine glands. The simple epithelia, which contain single layer of cells, and depending on the shape of cells, they are further classified into squamous, cuboidal and columnar epithelia. The simple epithelium consists of single layer of cells, and depending on the shape of cells, it is further classified. Look at the picture. This is the simple squamous epithelium. See, the height of cell is less, and then you can see the width is more, and see the flat nucleus. And this simple squamous epithelium is seen lining the blood vessels and alveoli of lung. The one lining the endothelium of blood vessels. So, the one lining the blood vessels is known as endothelium. Similarly, the simple squamous epithelium also lines the pleural, pericardial and peritoneal cavities, and there it is known as the mesothelium. So, endothelium is simple squamous epithelium lining the blood vessels. Mesothelium is simple squamous epithelium lining the cavities, and it also lines the alveoli of lung. Then coming to the simple cuboidal epithelium. Observe the difference. So, the cells are lying on the basement membrane, and the height and width. So, the length and width are equal in these cells, and the nucleus is rounded and centrally placed. This is the simple cuboidal epithelium, and it is seen in the thyroid follicles and on the surface of the ovary. So this is the simple cuboidal epithelium. Now let us look at the simple columnar epithelium, where the length is more than the width of the cell. This is the columnar epithelium. Because it is having only single layer, it is called simple columnar epithelium, and the example is the gastrointestinal tract. So now let us see the simple epithelia. So simple epithelium means single layer of cells. Depending on the shape of the cells, they are divided into simple squamous, simple cuboidal and simple columnar epithelia. And in this table you can see the features: cell shape, nucleus, cytoplasm, examples, functions, all are consolidated in one table. So simple squamous, single layer of flat, scale or plate-like cells. Width of the cell is more than the length. The nucleus is flat or ovoid near the center with little cytoplasm, and we have seen the examples: endothelium of blood vessels, mesothelium lining the cavities and the alveoli of lung, and the Bowman's capsule in relation with the nephron is also simple squamous epithelium. Then what is the function of simple squamous epithelium? It is for rapid transport and filtration of fluids, diffusion of gases and osmosis of molecules. Then coming to the simple cuboidal epithelium. It consists of single layer of cuboidal cells. The length and width of the cells are equal. Nucleus is round, centrally placed, and cytoplasm, when you compare it with the simple squamous, it is more. The examples for simple cuboidal epithelium is the thyroid follicle, the pigment epithelium of retina, surface of ovary, renal tubules and ducts of glands. The function of simple cuboidal is secretion and absorption. Now coming to the simple columnar epithelium. It contains single layer of cylindrical or rod-shaped cells. Length of cells is more than the width. The nucleus is oval and is close to the base. And another feature is all the nuclei are located at the same height, and it can exhibit modifications like the cilia, the microvilli and goblet cells. Cytoplasm is more when you compare it with the squamous epithelium. Then where do you find the simple columnar epithelium? In the stomach. We will find simple columnar, and with modifications we will see in the intestine. And the function of simple columnar is secretory. Now let us see the stratified epithelia. So we have seen simple epithelia, single layer of cells. Based on the shape of the cells, they are divided into simple squamous, simple cuboidal and simple columnar epithelium. Regarding the stratified epithelia, they can be classified into various types depending on the shape of the cells at the surface. Since stratified epithelia are multilaminar epithelia, they contain more number of cells. So, based on the shape of the surface cells, they are classified into stratified squamous, stratified cuboidal, stratified columnar, and transitional epithelium. So, among these, the stratified squamous and transitional are important. There is one more epithelium known as the pseudo-stratified epithelia. So it is something, it's a single layer of epithelium, but it gives stratified appearance because of the termination of the cells at different levels. But all the cells, they stand on the basement membrane but end at different levels. So that's why the pseudo-stratified epithelia, which is in between the stratified and simple epithelia. Now see the broad categorization of epithelia before we proceed further about the stratified epithelia. So the covering and lining epithelia are classified into the simple and stratified. Simple, 1 cell thick; stratified, more than 1 cell thick. The simple are again classified into different types depending on the shape of the cells. Simple squamous, simple cuboidal, and columnar. Then pseudo-stratified is also included here because it is only 1 cell thick. But because the cells are ending, if you observe the picture, all the cells are standing on the basement membrane, but they are ending at different levels. It is called pseudo-stratified epithelium. The columnar epithelium is further classified depending on the surface modifications of it. See, it is the non-ciliated epithelium, which is seen in relation with the gut, and this is the ciliated epithelium, which is seen in the uterine tubes. Then, coming to the stratified epithelia. So, stratified and transitional, they can be broadly divided because they contain more than 1 cell thick. Stratified, again they are divided based on the shape of the surface cells into squamous, cuboidal, and columnar. So, stratified squamous, stratified cuboidal, and stratified columnar. Stratified squamous is further classified into keratinized and non-keratinized. So, keratinized, where scale-like cells will be seen on the surface. Example is the skin. Then non-keratinized, you will not find the keratin layers. So they are seen in relation with the oral cavity and esophagus. Then the stratified cuboidal will be seen in relation with the ducts of sweat glands. Stratified columnar in relation with the excretory ducts of salivary glands. Then the transitional epithelium is also known as urothelium because it is seen in the urinary tract. So the examples for the transitional epithelium are the ureter and urinary bladder. So we have seen the broad picture of classification of the lining and covering epithelia. The glandular epithelia will be dealt in as a separate topic. Then, what are the general features of stratified epithelia? So, where are they located? They are located in the areas that are subjected to friction or wear and tear, and they have more than 2 layers of cells. The basal cells are columnar, the middle cells are polyhedral, the surface cells are variable. Depending on the shape of the surfaces, they are divided into stratified squamous, stratified cuboidal, and stratified columnar epithelia. There will be continuous replacement of surfaces by mitotic division of deeply placed cells. So from basal cells there will be mitotic divisions will be taking place and the last surfaces will be replaced. Let's look at the stratified epithelium you are seeing. So this is stratified squamous epithelium in relation with the esophagus. So we are seeing them containing more than 2 layers and they are regenerating from the below. The major function of this stratified epithelia is protection. So they are named according to the shape of surface cells into stratified squamous, columnar, cuboidal and transitional. Now let us see the images. This is the stratified squamous keratinized epithelium, which will be seen in the epidermis of skin. This is the stratified squamous non-keratinized epithelium, which is seen in the oral cavity and esophagus. This is the stratified cuboidal epithelium seen in the ducts of sweat glands. Then this is the stratified columnar epithelium, ducts of a larger caliber, for example, in the ducts of mammary gland. And then the other one is the transitional epithelium. It is known as the urothelium because it is seen in the urinary tract. The examples is the ureter and urinary bladder. You can see in this the basal columnar or cuboidal cells, the middle layer of polyhedral cells, and the surface cells or dome-shaped cells. Dome-shaped cells, you can see with the rounded nuclei of it. The other one is the pseudostratified ciliated columnar epithelium with goblet cells, which you will see in the upper respiratory tract and epididymis. So the pseudostratified epithelium, where all the cells will be lying on the basement membrane, but the apices are ending at different levels, and these are having the cilia in the case of respiratory tract and in the epididymis. And the goblet cells which will produce the mucus secretion will be seen in relation with this epithelium in the respiratory tract. In this table, you can see the features of the stratified epithelia, stratified squamous, keratinized and non-keratinized, the transitional and pseudostratified epithelia, which are the important epithelia when compared to stratified cuboidal and stratified columnar. That's why they are omitted in this table. So if you see the cell shape in the stratified squamous non-keratinized or keratinized, it will be same except for the apical flat cells in the non-keratinized and the dead scale-like cells which are cornified or hard in the case of keratinized epithelium. Otherwise, the features are same. Then, if you see the nucleus, that will be flat or ovoid and near the center in this epithelia. And the stratified squamous non-keratinized epithelium is seen in the oral cavity lining, the tongue, esophagus, vagina and cornea. Whereas the stratified squamous keratinized is seen in the epidermis of skin. The functions of which is the protection of deeper structures, both keratinized and non-keratinized. And in addition, the keratinized prevents absorption of water and prevents dehydration. And this epithelium is seen in the epidermis of skin. And coming to the transitional and pseudo-stratified, that's also included in this table for convenience. If you see the transitional epithelium, it contains the basal cells, intermediate cells, and the apical cells. The apical cells are dome-shaped or umbrella-shaped. Otherwise, the basal and the intermediate cells are same as in the stratified squamous epithelia. And if you see the nucleus, it's basal elongated, middle rounded, and superficial rounded. And the transitional epithelium is seen in the urinary system, starting from the renal pelvis, calyces, ureter, urinary bladder, and part of the urethra. The function of it is it acts as a barrier and for distension. Then there is the pseudostratified epithelium. The cells are columnar. All cells are attached to the basement membrane but end at different heights, giving the false appearance of stratification. And in this epithelium, the nuclei are at different heights. The examples for pseudostratified epithelia that are non-ciliated are seen in the excretory ducts of glands and auditory tube. The ciliated pseudostratified epithelium is seen in the respiratory tract, that is the trachea. And false appearance of cilia can be seen, which is known as the stereocilia, in relation with the pseudostratified epithelium in the male reproductive system. Example, epididymis. The functions of pseudostratified epithelium are secretion, propulsion, and protection. These are the functions of it. Now again see the total classification into simple and stratified. Simple again squamous, cuboidal, columnar. Then there is the pseudostratified epithelium. The columnar, ciliated and non-ciliated epithelium. The stratified divided into the stratified and transitional, stratified squamous, stratified cuboidal, and stratified columnar. Stratified squamous further classified into keratinized and non-keratinized epithelia. Now, let us summarize the functions of different epithelia we have seen. So, the function of absorption is seen in the intestinal epithelium. The function of secretion, example is the acinar cells of pancreas. The excretion, sweat glands, secretory part of sweat glands. The lubrication function, these are what are known as goblet cells in the intestine. So, the glandular epithelia we will consider separately at that time. We will mention about the goblet cells. The protection, example is the epidermis of skin. The sensation, example is the taste buds in the tongue. Then reproduction, germinal cells lining the seminiferous tubule. Transport, example is the ciliated epithelial cells of trachea. This is the additional information which you will revise when we are talking about the specific organs. This is the clinical importance of epithelia. There are what are known as epithelial tumors. Excessive erratic growth of epithelium causes these epithelial tumors, and these tumors can be benign, that is non-cancerous, or malignant, that is cancerous. What are the benign tumors? there are what are known as papillomas that arise from the cutaneous or mucous membrane. Then the malignant epithelial tumors, cancers. The adenomas are tumors of secreting glandular origin. So, we learnt about the epithelia, the definition, the classification, and examples of the different types of epithelia.